Statistics and probabilities, they are closely related chapter in the DSC curriculum. This short video, I want to show you some of the DSC questions on how to read the probability from statistics data. Now, namely, we want to look at stem and leaf diagram, bar charts, and pie charts. So first up is a stem and leaf diagram, all right? So this is how we read the stem and leaf diagram. For example, this 6, what does that mean? This 6 does not mean a 6. This 6 means a 56, all right? So likewise, this number 6 means 76, and this 1 means 91, all right? So we have to read the tens and the units from the stem and leaf diagram. And the total frequency of the data, we only count the leaves, all right? Do not count the stem. All right, so in this question we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Altogether 20 leaves. All right, so the total frequency is 20. Do not count the stems, all right, as the total frequency. All right, so let's make a note. The total frequency is 20, all right. So we want to find the probability that the selected member is not under the age of 74. So we have to cherry pick from the diagram. What are the leaves? What are the data points that is not under 74? All right. Note that not under 74 includes 74. All right. This is extremely important in the counting of this question. Not under 74 means that it includes 74 and up. Or anything higher than 74, including 74. So that means we cherry pick these. These are the data points that matches with the requirement. All right. Altogether, there are 1, 2, 3, 4, 5, 6. 6 data points out of a total of 20. So the answer goes to 0.3. All right. That is how we do the probability. We have the probability is the favorable outcome divided by the total outcome. All right, the one that fits our requirement, we call them the favorable outcomes, divided by the total outcomes. All right. So in this example, the favorable outcomes, they are those that meet the requirement that not under 74. Which means that we include 74 and everything upwards. So the favorable outcomes are these 6, all right? 1, 2, 3, 4, 5, 6, out of a total of 20. All right. So that's how we do the counting in the stem and leaf diagram. Okay. Now next we have these two examples on the bar chart. All right. Now let's take a look at the first example. The bar chart shows the distribution of the number of students on the keys owned by number of students. All right, so we want to find the total frequency in each bar. All right, the vertical axis is the frequency axis, the horizontal axis is the data axis. Okay, now the total frequency, there are 12, 16, 8, 4, and 4 respectively. So the total frequency is the sum of all these frequencies. And this sum goes to 44, right? This is the total frequency. All right, so let's look at the favorable outcomes. We want to select students who owns 3 keys, all right? So the favorable outcome will be this bar. All right, all these 8 students, they are the favorable outcomes. So it is 8 divided by the total frequency, 44. So after cancellation, it goes to 2 over 11. This is the answer. All right, once again, favorable outcome divided by total outcome. Favorable outcome will be those that meets the requirement. All right, total outcome will be the sum of all the frequencies. So maybe you may want to pause the video and look at the bottom question. It's almost exactly like the top one, right? We take the total frequency, we try to add up all these the heights of this bar, because the vertical axis is the frequency. The horizontal axis is the data, right? So if you add up all the data, all the heights of the bars, you add up all the frequency, all right, and that is the total frequency. All right. Total frequency goes to 60. And then you choose the favorable outcomes, all right? We want to select children that gets fewer than 5, all right? Now, fewer than 5 is very easy to make mistakes that you just choose this one. Now, this would be terribly wrong because we are not looking at students with 5 tokens. We are looking at students with fewer than 5. Fewer than 5 does not include 5. Alright? So you have to be very careful in the wording. How do you choose the favorable outcome? Fewer than 5 excludes 5. And then we only choose those that are less than 5. Alright? This would be fewer than 5. So we take the favorable outcome will be 20 plus 5. Alright, mind you. 3 tokens and 4 tokens. These are the favorable outcomes. Divide by a total of 60. So that is 25 divided by 60. The answer goes to 5 out of 12. Alright. So that the lesson here is that you must read very, very carefully from the description, alright, so that you can cherry pick the correct number to put in the numerator as your favorable outcome. The total outcome, usually you just add up all the frequencies together. Alright, but usually people were making mistake in the numerator in the favorable outcome. Alright. Not that she doesn't know how to count, but she misread the requirement of the favorable outcome. Alright? So pay particular attention to this one. Now next up we have a more difficult question, right? It's about cumulative frequency. Now the idea of cumulative frequency is that the number here, they are always in between. 0.35 is always in between the boundary between 0.3 and 0.5. Alright, so we know that all those with heights less than 0.35 will be just the number here. Alright, less than 0.35 will be the number here. Alright, so A equals to 2. We know that. Now, for all the numbers beyond, the cumulative frequency works like this. For example, if you look at what are the cumulative frequency for heights less than 0.65. So 0.65 will be here, pointed by the green arrow. So everything together less than 0.65 will be these two numbers added together. Alright, so the cumulative frequency works like this. These two numbers add up to x. Alright. And then by similar token, these three numbers adds up to 13. Alright, these four numbers adds up to y, and so on. Alright, this is how the cumulative frequency table works. These 5 numbers adds up to 37. Alright, so in order to find out x and y, we can do it one by one. First, for example, we know that a equals to 2 to start with. A equals to 2. And we know that in the green box, we know that a plus 4 equals to x. So right away, we have x equals to 6. Alright. Furthermore, in purple, we have a and 4 and b, alright, equals to 13. So we arrive at b equals to 7. Alright. And then in red, we have a and 4 and b and c equals to y. There are 2 unknowns in this equation, so we do not know c and y. But the next one can help. The orange one can help. We have a and 4 and b and c and 15 equals to 37, right? This is the orange arrow. So from here, we work out c equals to 9. With c equals to 9, we can go back and find out y. Y will be 22 in this case, right? Y will be 22. And z is just the sum of all the numbers. Z will be the sum of a and 4 and b and c and 15 and 3. Alright, so z altogether goes to 40. So x is 6, y is 22, and z equals to 40. Right, so this is how we how we navigate the cumulative frequency diagram. The probability comes in part B. Alright, once again, it's about cherry picking. If a plant is randomly selected from the garden, find the probability that the height of the selected plant is less than 1.25, but not less than 0.65. So we have to think about what are the total frequency that meets this requirement, right? The denominator will be 40. That is the total frequency, right? Z is the total frequency, so the denominator will be 40. Now, what worries us should be the numerator. which number shall we put into the numerator? All right. So we can look at the diagram on the left hand side and think about that. We have to choose those are less than 1.25, right? Now take a look at this. This is 1.25, right? So all the numbers here will be less than 1.25. All right, so there's A and 4 and B and C. Oh, but wait, it's less than 1.25, but not less than 0.65. So where is 0.65? 0.65 is here. All right, between 0.6 and 0.7. So not less than 0.65, but less than 1.25 would mean these two numbers. This is the place where you have less than 1.25, but not less than 0.65. Do you get this? Let me highlight this in pink. All right. This is the sweet spot. This is the favorable region. All right. So altogether, this is B and C. So what is B? B is 13 and C is 7. Oh no, B is 7. C is 9. All right. So this is 7 plus 9. 7 plus 9. All right. That is the pink region is the favorable region. So it's 16 out of 40. So after simplification, it is 2 over 5. All right, so this is the final answer to part B. All right, now this is the more difficult question because you have to navigate between the frequency table on the left and the cumulative frequency table on the right. And finally, in part B, you have to cherry pick the suitable boxes that contains the requirement less than 1.25 but not less than 0.65. All right. And then here's the last question. We have the pie chart. All right. The pie chart means that the whole pie chart together is 360 degrees. All right. And the population in each region corresponds directly proportional to the respective angle. All right. It's directly proportional to the angle. So it says that the probability that the student was born in spring, the probability here is 1 over 9. All right, 1 over 9. So that means that this x angle is 1/9 of the whole circle, right? So angle x will be 1/9 of the whole circle. The whole circle will be 360 degrees, all right? So this angle x, the answer will be 390 divided by 9 is 40 degrees, all right? That's how we read a pie chart, all right? The proportion of the sector is directly related to the angle, right? Divided by 360. All right, so in part B, we have to find the angle here, the blue angle about winter. All right, so we can do simple subtraction. Say this is theta, right? So we have theta will be 360 minus the right angle in autumn, minus the 158 in summer, and minus the 40 degree we just discovered in winter, in spring, sorry. 360 minus 90 in autumn, 158 in summer, and 40 degrees in spring. So angle theta turned out to be 72 degrees, all right. So the number of students corresponding in that sector will be the total number, 180, multiplied to 72, divided by the total circle, 360 degrees, all right. And this answer goes to 36, if I'm not mistaken, all right. All right, so let's review. In this short video, we look at how we read pie charts, cumulative frequency tables, bar chart, and also stem and leaf diagram, and obtain the probability from this statistics data. Thank you.